Here is part 1 of the Magnetic Interaction Lab for Physics 221. What we'll be doing is mapping the field of a bar magnet using a single compass. To do that, you'll place the compass near the bar magnet end and use your pencil to make a dot where the compass points. You will then move the compass and match up the tail with the previous dot and draw another dot where it points, and so on. And this will be a magnetic field line. You notice I've gone off the page, which is unfortunate. But we just keep going around. And just keep following it. And eventually get back on the page. And then we simply connect the dots. Oh, that is not great. And that is a field line, and as we know, field lines point from north to south outside of the magnet. So we will add arrows, like so. We'll then repeat this for the top of the magnet. And we would expect to see something symmetric, which it is shaping up to be. And again, we will connect the dots. And again, we'll have field lines going north to south. And so we get the general idea of what's going on above and below the magnet. If we look off the corners, we can see the field line heading like this. And if we do something similar on the bottom, we will see a similar field line. And again, we'll trace our dots. And then if we repeat that over here, we will get something similar. And then again on top, and again connect our dots. And add arrows as they come out of north, go into south. And so that is generally what the field lines for a single bar magnet will look like. If you continue to follow at other areas where I didn't, you would get similar idea. Something like this. And that is generally what you'd expect from a single bar magnet. Now what I'm going to use is this plastic rectangle filled with iron bars. and we are going to put it over the white paper to see easier, and we're going to mimic the two different field lines of like poles facing each other and opposite poles facing each other. So for these magnets, the red end is north, the yellow end is south, and so I'm going to put two north ends together, and you can see if you just look at half, you get kind of the single bar field, but where they meet in the middle, they go away from each other and you actually get a point of zero field in the middle. However, if you do like poles or opposite poles versus each other, you will notice that again on the outside you get similar to the single bar magnet, but where they meet in the middle, you get field lines going directly from one magnet to the other. And so that's kind of the idea we are going for the first part of the exercise, with mapping the magnetic fields of various bar magnet arrangements.